Hello everyone, welcome to another episode of Learn with Rhea. For today's episode, we will be talking about random servicing. Without further ado, let's start. So random servicing is under the man-machine process chart. So it refers to those cases in which it is not known when a facility will need to be serviced or how long the servicing will take. In random servicing, when we are going to get the probability of machines down, we have to use the formula P equals n factorial over m factorial multiplied by the quantity of n minus m factorial multiplied by P raised to m times Q raised to n minus m, where n is the number of machines, m is the total machines down, P is the proportion of machine downtime, and Q is the proportion of machine uptime. So in solving random servicing, we have to take note that the maximum number of operators is equal to the number of machines, because the goal of random servicing is to determine the optimal number of operators that can be assigned to a number of machines with a minimum cost. So let's have, for example, we have 4 machines. So the maximum that can be tested to it is also 4 operators. So we can say that the number of machines and the number of operators is directly proportional to each other. So in solving random servicing, we have to follow the following solution steps. So first is to solve for the probability that machines will be down. So we will use the formula P is equals to n factorial over m factorial multiplied by the quantity of n minus m factorial multiplied by P raised to m times Q raised to n minus m. Second is to calculate the lost hours. So number of idle machines times probability times available time. So take note that there will only be lost hours if machines down is greater than the number of operators. So third step is to calculate the available production time, and this is done by multiplying the number of machines and the operational hours. So fourth step is to determine the net available production time. So the formula of this one is available production time minus lost hours. Fifth is to determine the hourly average output. So the formula is net available production time multiplied by the production rate all over operational hours. So the last step in solving random servicing is to determine the total expected cost. So this is done by the formula total expected cost equals K1, which is the operator rate, plus N times K2, which is the machine rate, all over the hourly average output. So we are done with the solution steps in solving random servicing, so we will use it in our example. We have our example problem. So there are 2 operators who are assigned to 4 semi-automatic machines. Each one of the machines has the capacity to produce 15 units per hour and are expected to down 45% of the time. Determine how many operators is paid at an hourly rate of $12 per hour and machines run at $45 per hour. Operation time is given at 10 hours per day. So first thing that we have to do is to write the given. So we have 2 operators. So our N, which is 4 machines, our R, which is 15 units per hour, our P is 45%, so we can write it as 0.45. And our Q, which is the complement of P, so 1 minus 0.45, so we have 0.55. And our K1, which is the operator rate, $12 per hour. And our K2, our machine rate is $45 per hour. Since we are given with the operation time, so our operational hours is 10 hours per day. So that is the given in the problem. So we will then follow the solution steps. So first step is to solve for the probability that machines will be down. So we will input our answers in table format so that it will be organized and clean. So for the machines down here, we will write, since there are a total of 4 machines, so we will write 0 to 4 machines down. So 0, 1, 2, and 3, 4 machines down. So for the probability, we have to use the formula P equals n factorial over m factorial multiplied by the quantity of n minus m factorial multiplied by p raised to m times q raised to n minus m. So for the 0 machines down, our n is 4, our m is 0, our p is 0.45, and our q is 0.55. So we can see that in the given. So we have to solve, and we will get the answer 0.092. So for the 1 machine down, our m is 1 and the rest is the same. So earlier, for the 0 machine down, our m is 0. So for the 1 machine down, our m is 1. So we will get 0.299. So the same as 2 machines down, our m is 2, and the rest is the same. So for the 2 machines down, the probability is 0.368. And for the 3 machines down, so same, our m is 3 and the rest is the same. So for the 3 machines down, the probability is 0.200. And for the 4 machines down, the probability is 0.041. Next step is to calculate the loss hours. So remember that there will only be loss hours if the machines down is greater than the number of operators. So 0 machine down to 1 operator. So given that the operator is greater than the machine down, so there is no loss hours. So we'll have to put here 0. So 1 machine down to 1 operator. So 0 also, because 1 machine down is all equal to 1 operator, not greater than. So 2 machines down to 1 operator. So in this case, the machines down is greater than the number of operator, so there is loss hours. So we have, in this case, since 2 machines is to 1 operator, so we'll put here the available machine until the servicing will take. So for 2 machines down to 1 operator, so in this case, the machines down is greater than the operator, so we will put here the available machine. So we have, by the formula, number of idle machine is 1 multiply by the probability, which is 0.368, and multiply by the available time, which is 10. So the lost hours is going to be 3.68. So next, for the 3 machines down to 1 operator, so we have 2 available machines. So 2 multiplied by the probability, which is 0.200, multiplied by the available time, which is 10, is equals to 4. So for the 4 machines down to 1 operator, so the available machine is going to be 3 multiplied by the probability, which is 0.041, multiplied by the available time, which is 10. So the lost hours is 1.23. So for 2 operators, 1 machines down to 2 operators is 0. And 2, because the machines down is 0, because the number of operators is greater than the machines down. So next, 1 machine down to 2 operators is still 0. 2 machines down to 2 operators, so equal, it is still 0. So 3 machines down to 2 operators, so we have 1 available machine. So 1 multiplied by the probability, 0.200, multiplied by the available time, so it is equals to 2. And for the 4 machines down to 2 operators, so we have an available machine, when we have 2 available machines, so 2 multiplied by the probability, which is 0.041, multiplied by the available time, which is 10. So lost hours is 0.82. So for the 3 operators, so 0 machines down is 0. 1 machine down to 2 operators is 0. 2 machines down to 3 operators is 0. 3 machines down to 3 operators is still 0. So 4 machines down to 3 operators, so we have 1 available machine. So 1 times the probability of 0.041 times the available time, which is 10. So the lost hours is 0.41. So for the 4 operators, so 0 machines down to 4 operators is 0. 1 machines down to 4 operators, 0. 2 machines down to 4 operators is 0. 3 machines down to 4 operators is 0. And the 4 machines down to 4 operators, so equal, so still 0. So that is the lost hours in each operator and its machines down. The next step is to calculate the available production time. So the formula is the number of machines times operational hours. Machines, so our n is 4 multiplied by the operational hours. So it is given in the problem, so that is 10 hours per day. So 4 times 10, so our available production time is 40 hours. So before proceeding to the next step, we will have to total the lost hours first, because we will use it in the following steps. So the total lost hours in each operator. So for the 1 operator, so it is equals to, we have to add this one, 3.68 plus 4 plus 1.23 23. So we will now have a total lost hours of one operator of 8.91. For the two operators, we have the total 2 and 0.82. So we will have 2.82. For the three operators, we only have 0.41. And for the four operators, we only have 0. So that's the total loss hours in each operator. So continue with the solution steps. Next is to determine the net available production time. So the formula of this one is available production time minus loss hours. So we have to write here net available time. So for the one operator, we are still getting the net available time for each operator. So for the first operator, and for the one operator, I mean, so the available production time is 40 hours. 40 hours. So minus the lost hours of one operator, which is 8.91. So we are left with 31.09. So for the two operators, still our available production time is 40 hours minus the total lost hours of two operators, which is 2.82. We are left with 37.18. For our three operators, 40 hours available production time minus the total lost hours of three operators is 0.41. So we have 39.59. And for the four operators, so 40 minus the total lost hours of four operators is 0, so it is still 40. So that is our net available time in each operator. So head on to the next step. Determine the hourly average output. So this is done by the formula net available production time multiplied by the production rate all over the operational hours. So we will still calculate each operator. So output for the one operator equals the net available time of one operator is 31.09 multiplied by the production rate, which is our R 15 all over the operational hours, which is given in the problem, which is 10. So we have now 46.635. For the two operators, so the net available time for the two operators is 37.18 times the production rate, which is 15 all over the operational hours. So we have now 55.77. So for our three operators, the net available time for 3 operators is 39.59 times the production rate, which is 15, all over the operational hours. So it is equals to 59.385. So for our 4 operators, so the net available time is 40 multiplied by 15 all over 10. So the hourly average output of 4 operators is 60. So that is our hourly average output of each operator. So that is our hourly average output in each operator. So the last step is to determine the total expected cost with the formula TEC equals K1 plus N times K2 all over hourly average output. So we'll still solve it by operators. So TEC, since we have a total number of 4 machines, so we will solve the total expected cost of each operator also. So for the TEC1, the formula is K, so 1 multiplied by the K1, which is the operator rate. In the given, we have 12 plus N, the number of machines, which is 4, multiplied by the machine rate, which is 45, all over the hourly average output, which is 46.635 for the 1 operator. So we have now 4.12 per unit. So for the TEC 2 multiplied by the operator rate plus 4 multiplied by the machine rate all over the hourly average output of 2 operators, which is 55.77. So we have now $3.66 per unit. For our TEC 3, we have 3 times the production rate, which is 12, plus the number of machines multiplied by the machine rate, which is 45, all over the hourly average output, which is 59.385. So the answer is $3.64 per unit. So for the TEC 4, so we have 4 multiplied by the production rate, which is 12, plus the number of machines multiplied by the machine rate, which is 45, divided by the hourly average output, which is 60. So the answer is $3.8 per unit. So that's it, guys, for random servicing, and thank you so much for watching, and see you in my next one. Bye!